Next thing we're going to talk about is qualitative data, quantitative data, types of data, and types of measurement. So there are different types of data. Like I said, it's just information that you collect. So that could be categorical or descriptive, which those examples are listed: hair color, blood type, ethnic group, car or person drives. It's all information you have, but it's not like you can count up the number of observations you have for that hair color, for that blood type, but the information itself is qualitative. Or you can have quantitative data, which either counts or measures attributes of a population. That would be more like our example of height, amount of money, pulse rates. These are pretty straightforward. A little bit more important is the difference between discrete or continuous quantitative data. So these are both quantitative data, but discrete you have to think of as whole numbers: 1, 2, 3, 4, 5. It doesn't necessarily have to be whole numbers. It could also be halves, but there's no numbers in between. So if you're going whole numbers, there's no 1.5. You're either at 1 or you're at 2. The difference is with quantitative data, or continuous data, there's always a number in between. So if you have 1 and 1.5, you can have 1.25. If you're trying to find a number between 1 and 1.25, you can find 1.125. It's infinitely small differences, and you can think of that more as a number line. So that's kind of it for the types of data. Importantly, though, we can classify data into how we can measure it. And these levels of measurement are kind of in order. You start with nominal, and it's going to be descriptive but not give you a whole lot of insight. But by the time you get down to ratio, you can kind of do a lot more with the information that you're given from that level of measurement. So nominal is categorical. You're really still at the qualitative stage. You can't really rank things. One isn't necessarily better than the other. You just have people with blue hair, people with red hair, people with green hair. I don't know why I went for colored hair, but we're going to go with that. But so basically, if you have a group of people, it's just going to split the group. It's not going to really it's not going to give you numbers. Then you have ordinal scale. The best way to think of this is running a race. You have first place, second place, third place. Now, you can be in first place by a wide margin or first place by a hair. You don't really care. You won first place. And if you're second place, you could be second place by a minute, second place by a second, or second place by an hour. But if we have an ordinal scale, we don't know that, right? We just know who was first, who was second, who was third. Interval helps you with that a little bit more. Their example here is with degrees and with temperature. So you can have an idea, right, as to whether 100 degrees is a lot or a little bit hotter than 99 degrees, or whether 100 degrees is a lot or a little more hot than 80 degrees. But we can't give it as a percent, right? We know how much in terms of that unit, degrees, but we don't know how much that is relative to itself. But we can overcome that with ratio. So the important distinction with ratio scales is that there is a zero. This is perfect for exams, right? So if I have a 50% on one exam and 100% on the next exam, I did 100% better. I did twice as good. I know that, and I can compare it to the previous. I know how much. I know how much relative to the original score. And yes, I could have said 50 points better, and that would be more of the interval scale. But 50 or 100% better tells me, regardless of units, how much better I did. So that's the key for the levels of measurement, is kind of understanding how much. That's a key phrase, and I would try and think about that.